We're still getting AV connected right now, but since you're all here, and I'm going to be speaking about augmented reality and also by extension, computer vision, AI, machine learning stuff. I guess I'm wondering, what people's backgrounds are. So in case I go too deep, or at what level. Have you guys heard of things like semantic segmentation? Raise your hand if you've heard of that. 2 people. Okay. Have you guys heard about machine learning, but with computer vision, like not just like chatbots and stuff, Okay. 3, 4, 5, 6. Like about a handful, like 10 or so. I would say not as many. Okay, so I'll try to explain things a lot more. Feel free to ask questions if I am kind of going too fast on some things or glossing things over. So, is the AV working? And of course, everyone has heard about augmented reality, right? Show of hands? AR? Okay, that's most of the room. Like, okay, at least that buzzword is popular. And of course, IoT. Show of hands? Okay, also everyone, that's great. Okay, so that's showing that. What's going on here? One last thing. Yeah, so what's with the displays? Yep. Oh, so is this showing? Okay, great, cool.
Nope.
Here we go.
Okay, never.
Great.
You got it.
It's showing on this screen, but not on that screen. Okay, cool. So I'm Yosin. I've been working on augmented reality stuff for like a long time. And today I'm giving a talk that was originally titled AR Interfaces for IoT, but let's add in AI for machine vision, ML, computer vision. Okay, so this is primarily a talk about live demos, but I was told I should start with some slides. So let's do that. Where's my mouse? Okay, here we go. So let's start with kind of a story getting into why the tech is cool, or actually useful, not just cool. So as we all know, IoT is everywhere, but access is painful. Beyond IoT consumer appliances, municipal and enterprise infrastructures are controlled by connected devices, but yet you have to, go through a lot of dashboards, log in. It's not as fast as it should be, not as instantaneous. I mean, there are things that are just not instantaneous access. I mean, there's a big problem like control fragmentation. There's just too many different apps for all kinds of IoT different things, confusing UIs, and also just non-instantaneous entry points. There is also connectivity fragmentation. A lot of different ways, from like Zigbee to like different kinds of connectivity, and even just like authentication mechanisms. And finally, information fragmentation. I mean, ideally, IoT should be seamless, and all of the information you want from the devices should be seamless and transparently flowing, but there's just a lot of different gateways and besides the access protocols. Let's see, I kind of got kind of abstract here. Information should be fluid and accessible like a uniform melted metal alloy. It's like the junkyard, right? What if information could be like, melted alloy instead of like a bunch of disjoint cars? That's the ideal. And so the solution, getting into the very interesting stuff here. So I want to introduce here we go. I want to introduce a concept that's computer vision for ubiquitous access. The idea is that if you can see it, you can control it. So as a really quick overview that I'm going to actually go into each of these 4 general topics in more detail. So starting with object recognition, you can recognize IoT objects at the speed of sight through computer vision. Just point your phone and it recognizes the object. And also another method is, I call it contextual ambient understanding. So even by just kind of scanning a bunch of objects, the system can recognize the context, like this is the living room, this is the auditorium, this is the lecture room or something. And also another form, reassignment tracking. So this is quite common for things like beacons, right? So beacons are often used on things that are it's kind of tiny, so you kind of can't really see the beacon, but you know the rough GPS location of it. But oftentimes it's like, what if you have a bunch of beacons in kind of the same room? So you can assign a different object tied to that beacon. So I call that reassignment tracking. And also in-world placement. So once you have the recognition of the object, kind of like a primary key, you can place the UI in the real world, like the AR style and stuff, in context where it makes sense. Okay, so object recognition. So this is a really quick overview of a few topics in machine learning. So you can recognize specific objects and also general classes of objects, and such as dogs and people, and other diverse objects. And also, of course, there are different kinds of recognition feedback. Other than giving you just what it is, it can tell you there's a bounding box around the dog or like the people. And I'm going to jump into live demos, but just so we get terminology straight here. And then there's also sub-object bounding boxes. Like say you recognize a person, you can actually have your algorithm actually, this is the face, this is like, the body, this is like the hand. So it's like, okay, the person, rectangle, and like, the sub-objects. Or say it's like a tool in your machine assembly line. It's like, this is the handle, this is the actual bolt, it's sub-object bounding boxes. And there's also semantic segmentation. And this is actually where this thing should be playing right now. Here we go. So this is an example of semantic segmentation. There's also a kind of a much more specific version of that, which is instance segmentation. So the idea is that not only do you have a bounding box, it actually recognizes the kind of collision bounding thing of the object. So with semantic segmentation, you have kind of only like a frame by frame kind of very short-term memory. But when you have instance segmentation, it recognizes that through many frames of the video stream that that's the same car. And a whole lot of very interesting applications would be possible from that, as you may have seen from like all the interesting driving sort of things going on. Cool. So there's also ambient understanding. And that's context-dependent recognition. And so, for example, a computer can recognize that the set of objects here, people, chairs, camera, this is like a session room, or like, chairs, computer, desk, and office, and so on. It's basically getting towards an artificial general intelligence. Or say dogs and like, someone speaking. Perhaps it's turning into kind of like a circus. Yes. So here we go. Breezing through this, I want to jump to demos soon. There's also reassignment tracking. So say an example might be, say you have a beacon tied to your Magic Yoda Lego, but that's all the way like, well, you have identified that you lost it at Necker Island. I've actually never been there, but it was just a fun location to put a beacon in. Computer vision can scan all your Lego blocks and go, okay, it's actually right here, instead of like this, wide sort of margin of error from the GPS and stuff. Phase 1 beacon locality, the beacon tells you roughly if you're in the right area, but the phase 2, the computer vision portion, you have the scene detection to understand where exactly is it. It's actually right here. Sometimes it's visually hard to see it for us, but for, if the machine vision recognizes that, it's very straightforward for it to just, that's right there. Okay, in-world placement, there's a lot of interesting things you can do. Like, what if you can look into the wall there and you see X-ray cables of, what's in the cables over there behind the walls, right? What if you can look inside containers instead of having to, a lot of different sort of, steps to, inventory that. And also, what if you can read meters at a distance and all kinds of control UI things. Okay, cool. So I'm going to start showing demos that's about I guess I call it A-Reality 3D IoT. It's universal access at the speed of light. So starts with like, you start with input, camera, and context, and you can also have additional inputs like GPS and direction. And then that loads controls that make sense. And you can have a lot of interesting things that, like X-ray vision and projection. Okay, cool. Everyone, go to iot.areality3d.com. These are WebGL live demos, and you guys are welcome to play along with these. Cool. All right, so going to switch over to mirror displays. Here we go. Okay, great. So I've preloaded these WebGL demos, and they're all available at iot.areality3d.com. So we'll start with kind of the really old sort of home example that I kind of started with this last year, but I've added a lot of other interesting things for other uses. So what you're seeing through the iPhone is the augmented reality view. What you're seeing, I guess, peripheral vision is like, what you see without it. It's like, okay, you don't have all of that additional information. So this is an example of object recognition here, where that IoT connected coffee maker is recognized, and you're able to just, at a glance, know all that information. And if the API actually allows for, read and write access, then you can, like for a Nest thermostat, you can actually change the temperature. And then some things like sunlight, that's just, I guess read only. But it's good to know that that plant has plenty of sunlight and it's, well watered and stuff, so you don't have to get off the couch and go water it and stuff. So there's also other interesting applications. So you can also bundle in advertisements into this IoT platform, right? So instead of just seeing like magazine stuff, you see all kinds of interesting augmentations on other potential advertising services. So walking inside this room here, you can see some interesting additional IoT things. A hack that I did in 2016 that was kind of interesting was that I created an AR thin client for the Raspberry Pi. So this is kind of like a meta example, like inside a virtual sort of environment example of that AR example, just so I don't have to bring too many different devices with me, and it kind of is a broad overview of what is possible. And also for fun, the thin client was actually in addition to recognizing the object, it projected onto the Raspberry Pi, so you have kind of a floating, hollow screen there that you can like shell into and stuff. And feel free to play with it, like enter in shell commands into that. We're just going to go through this faster so we can get to the other demos. So there's also, I think this is most of the sensors. There's other rooms to explore if you want to check out more things. I want to jump to, this version. Okay, so I call it kind of the Vacation Alpine Home version of it. So it has a few new features. So there is, let's see, here we go. Yeah, so plant stuff. Okay, so let's go straight to, I'm going to make it a little bit brighter. Here we go. I can actually see my screen now. Okay, so the same thing in there for our connected IoT things, but you can actually walk outside. So this is where the beacon tracking is kind of interesting. Say you have like beacon tracking on like some animal out there. Oh, let's actually walk outside through the other side. So I'm kind of going out of order right now. Before we go outside, I want to show for fun another IoT sort of thing that I've actually recently tried to install at my own home, which is connected curtains. It's kind of a cool thing. They have that like in movie theaters and stuff. So basically, what if you could just, okay, you see the curtain thing and you can, open up a UI and you can just like close it or open it and just like freeze it right there. So just kind of like very simple interfaces that just make sense. But, the whole point of it being transparent, you point and it loads. It's object recognition at its, most useful. And so, okay, now we're walking outside. So this is like kind of an alpine vacation sort of home here. And so looking outside, we actually have, I guess it's kind of like a, backyard zoo here. That bear there, the brown bear, endangered species, I think, is, or protected species in California. It actually has a beacon tracked on it. So, so in addition to knowing the GPS, we can also use the computer vision to identify, okay, exactly, that what that is right there. So it is a brown bear. So this version actually has a little zoom in dial. So if you're checking it out on your computer, you can actually, zoom in and look at the bear. It's not very exciting because it's kind of hiding behind the tree, but if you walk to a different angle, you can see more and stuff. You can adjust this here, and cool. And zoom in. And we're not going to shoot the bear or anything, but at certain angles, you can actually, see its expression as it's idling and stuff. Yeah, anyways, so, okay, let's move on to, I guess, things that are perhaps of interest in your workplace. This is, I call it kind of the AR interfaces of IoT, the office version. So a very interesting office use is you could look here at the cabinet, and what if you could have an AR IoT cabinet? So it recognizes the cabinet, and it's actually showing you the documents that are actually inside your cabinet. This is assuming, of course, you digitize the cabinet. And so it's kind of an interesting way to access the original content. And also the plant meters. And okay, so another format of doing this is you could have video streams going on in your cabinet. In this case, there is a video, an actual camera inside this cabinet. And apparently someone put their bunny rabbit in this cabinet. And, the fun part with AR is that you can, kind of have an X-ray version of, the cabinet here. So it's a regular cabinet, but, through the AR view, it's live streaming whatever is on the camera. Yeah, I think it's a little bit too small to fit a corgi inside, but the bunny rabbit seems to be having a lot of fun with the office sort of things in the cabinet. So these are just kind of some examples of using different ways of AR, machine learning, computer vision sort of stuff for interesting and also very useful sort of things of accessing your IoT things. Okay, so this is the city version. So now instead of walking around with your phone in your hand, it's properly on a dashboard so you won't get in trouble, right? Although you can just easily, so let's drive to a traffic light here. So this is a kind of a citywide example here. And you can press the iPhone to hold your iPhone. And so you see that it recognizes there's a traffic light. So you can actually, okay, this is a little bit bleeding edge, so it works to load the interface at some angles, I think. Looks like got 3 cast off on this. So the idea is that you can point at a traffic light to be able to load a UI that gets you more information about the traffic light. And okay. It's loading right now, but I actually forgot to show kind of another interesting X-ray view in the office. So another interesting view is you can actually just turn on X-ray view and just kind of see what is, the piping underneath your office. Or say the electrical wiring that is on, that is connecting, your electrical outlet or something. This is kind of just a very rough visualization, but assuming that you have the data somewhere, this can easily just be, made accessible. So you just point at the wall and you see the Ethernet cables going through there, or where it is running, and that's sort of assuming it's documented, and the information is metal flowing smooth, I guess. Okay, getting back to the city example. Okay, so. Back on folder. Okay, let's try this again. So, okay, this is kind of bleeding edge. I literally just built this a layer today. So this might actually just be, oh, here we go. But yeah, it should be loading the historical information about the traffic light, as well as a camera feed from it, assuming this UI triggers. Sorry for the bad first-person navigation. Hopefully no one is getting nauseous from my bad driving. Right, so here we go. How much time is left? Okay. Okay. Let's try this one more time, or we'll just skip on to the next demo if this is not working. And okay, I guess we'll just jump straight to actual live AR demos for now. Okay, so I guess I'm going to request switching to the phone and then switch back to the computer, I guess. Cool. Okay, so yeah, this is an example of just basically unoptimized YOLO running on my iPhone. This is a regular iPhone. We're not using multiple cameras, using just the RGB single camera stream. And it's not showing anything super fancy in my opinion, just kind of bounding boxes, recognizing, and this is actually not the best lighting condition. It's kind of, yeah, and it's doing okay-ish. So it's in real time. Check out the audience, people. Yay. Hello, audience. You're on the big screen, and you're being recognized by machine vision as people. Okay, so for fun, I hacked together a really last-minute demo, and let's see if it works. Here we go. I may need, oh my gosh, and you may need a flashlight. It's really dark up here. Come on, hello cams. Okay, it's recognized. Okay, so this is for fun, like an IoT dog, IoT corgi. Okay, so it should recognize the dog, assuming the lighting is not horrible, and load up a command center for commands for the corgi. Oh no, that's the projector. Okay, so oh cams. Is there a way we can turn the stage light to like have a spotlight or something? Like maybe right here. I mean, it's kind of recognizing in some frames.
Yeah, we can all go up here.
Oh yeah, everyone just come crowd here and we'll like
It's gonna help very much, actually.
It worked really fine in the day. I tested it like outside in like regular lighting, and so this literally was a demo I just hacked together. Like yeah, so audience, feel free to come and like bring your phone so we can have a giant flashlight here to give. This dog loves the limelight actually. She's kind of like a staged sheep. She loves the attention. Yeah. So everyone come, and also you can come check out this live demo too. All right, cams. All right. People are coming here for you. Yay! Okay. All right. I think I need to actually. Okay, Cami, sit, please. Come on. So this IoT dog may or may not listen. So this is where you have connectivity, communications issues. Okay. It recognizes this one frame. Okay, here we go. 2 frames. Okay. Oh, come on. Okay, she wants to like say hi to everyone. Okay, so anyways, it loads up a UI where it lets you say commands like sit. Come on, Cami, sit, please. Good girl, sit. Come on. Yeah, so this is an extreme example of connectivity communications issue with your IoT device, and and also like unusual lighting. for fun, I'll just like Google up some dogs on proper lighting and stuff. Here we go. We'll just choose a dog. Anyone have a preference? Let me know which dog you want to choose. Or we could go to cutedog.club. Okay, great. So it says Corgi detected. IoT Corgi is awaiting commands. Okay, so you can give 2 commands. You can say sit, and it's supposed to do a speech, right now. It's a voice from AWS Poly. It kind of sounds like the voice in the keynote yesterday. Cammers, sit, come on. Cammy, sit, come on, sit. Okay, so she's trying to assert her dominance right now on stage. She's usually very, very, she likes sitting. Cammy, come on, sit. Come on, Cam, sit. Sit. Let's see, let's use like a darker picture so you can kind of see the screen. Okay, great. Corgi detected, so you can, ask it to say down or sit, but the audio is kind of not coming through. So, yeah, but if everyone's up close, that audio should be heard and stuff. Okay, can we switch back to the laptop? And then, oh, is she? It's getting torn down like pretty much right now, right? Down. Okay, so I mean, it actually says that, like once I disconnect from this, right? So anyways, so yeah, iot.aready3d.com, check out the simulated versions of these different sort of environments. The key take-home points are turn real-world objects into your IoT primary keys. So imagine you are a primary key to your whatever access data that, in a way it's an extension of IoT to like personal data locker or something. So yeah, turn any object, including a corgi who's trying to eat the stage, but she's helping you guys tear down, right? And also IoT at the speed of sight. You just see something, you can access the whatever data is available. And I think I may have time for questions. I actually have 2 minutes for questions. Any questions? Cool. Okay. Yeah, questions.
Yeah, I think this idea of being able to view through AR elements that you can control through the AR interface, that maybe you're like editing a physical controller, like the curtain example. That seems pretty interesting as a UI paradigm. So I was just wondering if you've seen other examples of that, or is that just something you've been thinking about, or like where did that idea?
You mean like on a projective, or just kind of having an icon going, this is something that has a recognized point in the system?
Yeah, just the idea of being able to look through your looking at the real world and being able to tap on things that have physical, controllers that you're then actuating through that tapping mechanism. It just seems like a neat way to control the environment. So I don't know if you've seen that elsewhere.
I've built it myself and I use it myself. Elsewhere, definitely we've seen this probably in Black Mirror movies like that. Just a futuristic TV, yeah. But it's possible right now, so that's kind of the really fun part, I guess. I haven't really seen it used very much, but now you guys have seen it, and maybe we'll get to use it with your applications and stuff. Yeah, cool. Yeah, question?
I'll just get your mic.
Okay.
Sorry. Running.
You might have gone over it earlier and maybe I didn't understand, but would you mind elaborating on the process of digitizing like something that you would want to interact with in this way?
Okay. I'll jump back to kind of a slide so that can kind of maybe add some visual context. I kind of glossed over this part here. So I guess let's go back to like object recognition, right? So there are a lot of objects that have a lot of sort of general models that are very common, like that. What I just used is YOLO. It's like an open source model. Anyone can just download and stuff. you can actually custom train your machine learning modules to like say you only want to track doorknobs and only like vintage doorknobs or something. There are a lot of specific subsets. What you just need is enough training data or enough different pictures for the machine learning to be able to extrapolate. Oh, yay, this is has these features and stuff. So pretty much anything can be trained to be recognized, and I think that gives a lot of very interesting potential for what I was talking about earlier about the, I'll put this on a big slide here, turn real-world objects into your IoT primary keys. So like, yeah, I could point at you and just like, okay, access your IoT personal data and stuff. And so people, and also face tracking is very, very solved and stuff. But I think also that's very sort of invasive. I think that the very interesting use case is that beyond it being invasive and creepy, it's useful to be able to like point at, say, your thermostat or like say, like your office wall and go, okay, it has wiring here, you can't drill into it or something, So I think there's a lot of very good informational ways to, use this technology for non-invasive, non-evil purposes. Cool. Cool. Any sort of, I guess, am I out of time or? Okay.
There's another question.
Okay, yeah.
You can take another question. Any more questions?
Cool.
I just want to make a comment. It's interesting how, I'm watching all this. A lot of this is new for me, right? And I'm thinking to myself, person of interest. And I'm thinking that, just in a matter of, a few short years, wow, where this is going to be
It's really fast,
going.
yeah.
And then you take this and you interface it with robotics and already what we're doing with AI, and wow, we're really moving. That's what I see.
Yeah, the singularity is there, right? It's both scary and also it's exciting. It's like a roller coaster ride, and it's getting to a crazy point. Yeah. So yeah, imagine the future of communications beyond text and voice, but the whole rich visual field of contextual access, that sort of stuff. Yeah.
If you decided to play like hide and seek with a robot in the future, good luck.
Yeah. Well, what you do is you kind of train the robot to have human disabilities and handicaps, right? Yeah. Cool. Well, thank you guys. Yeah. Cool.